In this video, we're going to be taking a look at 101 tools that you should learn when starting Blender 3D as a beginner. Keep an eye in the description and the comment section for links to other videos related to each of the tools that we will be covering in this tutorial. To access the splash screen while working on your project, go up to the top corner where you can see the Blender logo. Left click to bring up this menu and select Splash Screen. From here you can see the current version of Blender, access new file templates, open one of your older files from the file browser or one of your most recent projects. If you want to start a new project in Blender, just go to the File menu, select New, and then choose from any of the templates listed here. For example, we can go to 2D animation and it will create a new project using the 2D animation template. To load one of your more recent files, go to the File menu, go to Open Recent, and you will have a list of all of your most recent .blend files that you have been working on. This list can be edited in terms of its length in the Preferences panel located under the Edit menu. To access the file browser to open an older project, go to the File menu and select Open. From here, you will be able to access your drives as if you were using a traditional file browser. Simply locate where you store your .blend files within the file browser, select the blend file that you want to open, and then click on the Open button here. Let's say we made changes to our project, but we never actually saved the file. I'm just going to create a couple of random changes so that the scene is noticeably different to what it was before. Next, I'm going to go to File and I'm going to quit Blender. I'm going to choose not to save, so let's say we have forgotten to save our project. I'm then going to re-access Blender, and when the splash screen comes up, we will have the opportunity to recover our last session. If you miss this, go to File, go to Recover, and choose Last Session from this menu. Left click, and it will restore the temporary file that we had created previously. To save a project, just go to File, and then choose either Save, Save As, Save Copy, or Save Incremental, depending on your current settings. Typically, you'll either save or save as. If you are saving a project for the first time, choose Save As. This will open a file browser where you can then access the location where you want to save. Currently, I'm in the temp folder, but I can navigate anywhere I need, such as the desktop, give my project a name, let's just call it Project, and then select Save As. Once saved, you should be able to see in the top corner when using Windows what project you're currently using. From this point, just go to File and Save whenever you want to update the save file of your project. To access the settings relating to Blender itself and the user preferences, go to the Edit menu, come down to where it says Preferences and left click. This will open up a separate window called Preferences. From here, you will be able to change many of the core settings within Blender 3D. To change the size of the text elements in Blender to best match your display size and resolution, come up to the Interface subsection in the Preferences panel. The very first option relates to the resolution scale. By default, this would be set to 1. As you can see on my device, the text is far too small, so I increase it all the way to a value of 2 so that it is easy for me to see the text elements but they are not too big for the interface itself. In Blender version 4.3, we can go as high as a value of 3 for the resolution scale, and as low as a value of, I believe, 0.5, but even for me, it's very difficult to read that text. The correct resolution scale is going to depend on your display size and your display resolution. To change the language that you are using in the Blender interface, go to the Interface subsection in the Preferences panel. Scroll down to where we have the Language menu. It's currently set to English, which is the correct language for me, but you can select the drop-down and from here choose from a wide range of languages. For example, I could go with Turkish, and it would change the language interface to Turkish. To be able to use the GPU for rendering in Blender, we need to go to the Preferences panel and then go to the System subsection. Come up to the top where it says Cycles Rendered Devices. By default, it should be set to none. Depending on the GPU that you are using, you will choose CUDA for older NVIDIA GPUs, Optics for newer NVIDIA GPUs, HIP for AMD GPUs, and One API for Intel GPUs. Because I have an RTX 3080, I would choose Optics, so I would ensure that the GPU is ticked from this list, and I would be ready to use my GPU for rendering in Blender when using the Cycles render engine. To select an object in the 3D viewport, simply left-click. The object will be highlighted in a light orange colour. If we left-click on the cube object, you will see the highlight that surrounds the model. The same applies for other object types such as this camera object and the light object. To select multiple objects in the 3D viewport, simply hold down the Shift key and then left-click on additional objects to select them. The active object will typically be the last object that you select in the viewport. In this case, it is the camera. The highlight between the active object and other selected objects will be different. In our case, the bright orange is used for the active camera object, while the light and the cube objects use a more reddish orange tint. To rename an object in Blender, come over to the Outliner panel, which is this area here. You will see the names of each of the objects in your scene. To change the name of an object, simply double left-click and you'll be able to rename that object. Let's change this cube's name to Box. Press Enter, and now we have changed the name of the active object here in the Outliner, here in the Properties panel below, and also here in the 3D viewport, so Blender recognizes the new name of this object. The 3D cursor in Blender is the small red and white circle that is located at the very center of the Blender interface, where the red and green lines here intersect. This can be used for many different purposes. Perhaps the primary purpose is to add new objects at the location of the cursor. To move the 3D cursor, come over here to the tool shelf. The second option is for the cursor. Now, if I left-click anywhere in the interface, it will change the position of my 3D cursor, and I can click and drag to reposition as well. When you are done positioning the 3D cursor, a top tip is to make sure that you are no longer using the cursor tool, as while this is active, whenever you left click, you will be manipulating the cursor and not the objects in your scene. so make sure to come off of this option when you're finished moving the cursor. To add an object in Blender, come up to the Add menu that is located here. Left click and you will have a variety of different object types to add. Typically, we will want to add mesh objects, such as our cube or potentially a UV sphere. Choose the object you want to add, left click, and that object is going to be added to your 3D viewport, as well as the outliner panel which is located here. To delete an object from your scene, you first need to ensure that it is selected by left clicking. In this case, we've selected the sphere. To delete the object, the quickest method is to use the delete key. Just press the delete key on your keyboard and it will delete the selected object. In addition, if we were to add an object, again, we can delete it by pressing the X key, and this will bring up a prompt, which will allow us to either delete the object or cancel the operation. In this case, select delete. To move an object in Blender, first select that object. Then select the Move tool located in the tool shelf. If you cannot access the tool shelf or it is invisible, you can use the T key on your keyboard. So if your 3D viewport looks like this, you can press the T key to open up the tool shelf. Left click to select the Move tool and this will open a gizmo. You can then left click where this white circle is and begin to move your object around in 3 dimensions. Alternatively, you can also move your object by pressing the G key after you have selected the model. The highlight that surrounds the object will become white, and you'll be able to move your mouse around to move the object in 3D space. To confirm the new location, simply left click to confirm the operation. To rotate an object, we can use the Rotate tool located here in the tool shelf. Bring your mouse cursor within this white circle, click and drag, and this is going to rotate based on the view of your viewport. You can also use what is known as trackball rotation if you bring your mouse cursor towards the center. This will freely rotate your object in 3 dimensions regardless of the view in the viewport. In addition, we can also rotate by using the R key. Press R on your keyboard to enter rotate mode. Then we can begin to rotate based on the view of the 3D viewport. If you want this to be a bit more free-flowing and rotate in all dimensions equally, you can press the R key a second time, and this will enable what is known as trackball rotation. Again, we can confirm this operation by left clicking. To scale our object size, come over to the tool shelf and select the Scale tool. Then bring your mouse cursor within the white circle, click and drag, and this will allow you to either increase or decrease the size of your object. Alternatively, we can scale by using the S key. Press S on your keyboard, and then you should be able to scale the size of your object once again, and when finished, you can left click to confirm the operation. When moving, rotating, or scaling an object, you can lock that transform, as it's called, to a specific axis. For example, when using the Move tool, we can lock to the X-axis, which is the red arrow, the Y-axis, which is the green arrow, or the Z-axis, which is the blue arrow. So I can click and drag on the green arrow here, and this will allow me to move the object on only the Y-axis. I can click and drag on the red arrow, to move my object along the x-axis, or I can use the blue arrow to move my object along the z-axis. Just click and drag and release the left mouse button to confirm the location. This also works with rotation. We can see that we have 3 coloured lines, red for X, green for Y, blue for C, and we can click and drag to rotate on a single axis, whichever axis we need to use. Finally, we can also scale on an individual axis. Again, we can do so on the Z, the Y, or the X axis. When working with the Move tool or the Scale tool, we have the ability to move along a plane, which is effectively 2 of the 3 axes in 3D space. With the Move tool, we can select one of these coloured squares. The blue square allows us to move along the Z plane. This is the same as moving our object along the X and Y axes, but not the Z axis. If we were to use the green square, we can move along the Y plane, which moves our object along 2 dimensions, X and C. And then finally, the red square allows us to move along the X plane, which allows us to maneuver across the Y and Z axes, but not the X axis. This is also doable with the Scale tool. Again, we can select any of the 3 squares, and it will allow us to scale along that specific plane. The scale cage is another way of scaling up your objects. To access the scale cage, click and hold where we have the Scale tool in the tool shelf. This brings up a secondary menu. Select Scale Cage from this list. A variety of white dots will be positioned around your object in a cube-like manner. This won't change regardless of the shape of the object itself. We can click on any of these white dots and it will scale along the appropriate axes. Select a dot in the center of a face and it will scale on that axis, in this case the Z axis, but it will only scale in one direction. By comparison with the Scale tool, if we were to use the C axis, we would be able to stretch our cube in both directions. However, with the Scale cage, we can drag it in a single direction. If we were to select one of the white dots at the center of these edges, we would be able to scale in 2 directions or 2 axes. In this case, we're scaling from the X and Y axes, but not the Z. Finally, we can click and drag from one of the corner dots. This allows us to scale in all 3 dimensions, using the opposite point as our anchor. So if I was to scale from this location, this would act as the anchor. Click and drag, and we can scale from that position in all 3 axes. The Annotate tool is useful if you want to take notes on screen. Just access the Annotate tool from the tool shelf. You will then be able to draw in any notes or drawings that you want to make to help with your project. For example, I can just create a little cube drawing here. Will probably be awful. And that's an example of an annotation. I can also change the color of my annotated notes here. Just left click on this blue block and you can change the color of your annotations. If you want to remove an annotation, just go to where it says Note, left click to bring up this menu. You can change the name of your annotations here, or you can select them and click on this minus button here to remove any annotations that are selected. Navigating in 3D space is best used with a 3-button mouse. Press down on the middle mouse button, which also acts as the scroll wheel on your mouse, and then move your mouse around. This will allow you to navigate in 3 dimensions using a point of reference. Typically, that point of reference is going to be the very center of your scene, but this can change based on how you navigate. Additionally, you can come up here to where we have this interactive axes. Wait for the grey circle to appear, click and drag using the left mouse button, and you will be able to navigate in 3D space using this method as well. If you want to access very specific views known as 2D views, then you can use the interactive axis to do so. For example, if we want to look at our object using the X axis, just left click where it says X here. If we take a look, we're now using the right orthographic view in our viewport. So we're looking at our object from the right side. We can come up here and click on the Y option to view the object from either the back or front. If we left click again, we're currently on the back view. If we left click on the Y button again, it will shift to the front view. If we select C, we can view from the top, and if we select C again, we can view from the bottom. If you have a number pad on your keyboard, you can use the number pad to move into these 2D views as well. If we press 1 on the number pad, we get the front view. If we press 3, we get the right view. If we press 7, we get the top view. And if we press 9, we reverse that view. So if we go 1 and then 9, we get the back view. 3 and 9 for the left view, and 7 and 9 for the bottom view. To access the orthographic view, we can press the 5 key. This will allow us to move into an orthographic view of our viewport, where depth is not applied. To move into perspective view, where depth is applied, press 5 again. This moves us back into our user perspective view. Alternatively, we can come over to the side and select this option here that looks like a grid. This will allow us to switch between perspective and orthographic views. We can use the measure tool to measure the length of our object on any given side. This is best used in combination with a 2D orthographic view. For example, let's go into our front orthographic view, come over to the tool shelf and activate the measuring tool. Now we can click and drag from any point, and this will give us a rough estimation of exactly how long our object is based on where we start and finish with the measure tool. Just click and drag from any point, and this will add a new point of reference for measuring each side of your object. You can add as many of these as you wish. If you click and drag on an existing point, you will be able to move it around. So just keep that in mind while you're creating these measuring points for your objects. To change your orientation, come up here to the center of the 3D viewport's header. Left click, and from here you'll be able to change to the various transform orientations that are available. For example, let's say we were to rotate our object on the Z-axis. Then we go to move our object. You can see that rotating hasn't changed the positioning of the arrows because this relates to the 3D world. If we change from global to local, you can now see that the red and green arrows have been shifted. They are following the X and Y values of the object itself and not the 3D viewport. Again, if I was to rotate this time on the Y axis and return to the Move tool, you can see this time all three of our arrows are pointing in a direction that they would not be if we were using the global orientation. Global is for the viewport itself, local is for the object based on its rotated values. We can lock or snap our transforms in increments by using the snapping tool. The easiest way to activate is to click on this icon here that looks like a magnet. Open up the menu to the side of this icon and make sure the snap target is set to increment. Now if I press the G key to move my object, it will move in increments of single meters. The unit of measurement may change depending on where you are in the world. In this case, if I were to rotate and along any axis, it would rotate freely. If I activate the rotate tool, click and drag, it would do the same. And the reason why here is if we go into our menu, we're currently only affecting the move transform. We can select rotate and scale so that we can snap in increments on all of our transforms. Here we can snap in increments for rotation, and we can also do it using the scale tool as well. We can snap objects to each other. First of all, we need to add a secondary object. So I'm going to go to Add, Mesh, Plane, and I'm going to use the Scale tool. I'll just use the Scale S key to bring it up, and then we're going to move it down. Now I want to take my cube object and I want to snap it to the surface or the corners of my plane. To do this, activate the snapping tool, open the menu and change your snap target. In this case, let's go with the vertex option. This will allow me to snap my object to the plane's corners. Move the object across, and you can see that it sort of hovers over, but it doesn't snap. If we use the G key though, for a bit of free motion, and hover over each corner, you can see the cube will snap to that corner. To move the object origin, which is going to be the orange dot in the center of your object, come to the Options menu located here. Left click and choose for your transform to affect only the object origin. Now we'll move with the Move tool. We can click and drag, and you can see this time only the object origin is moved. The mesh of the object remains in the same place. We'll go back to Options and turn off this tick box. Now, if we were to move again, both the object origin and the geometry of the object are moving, same as before. This can affect things like rotation and scale. If we go to the Rotate tool and rotate, you can see the behavior of the geometry is very different. It's now rotating around the object origin based on its new position. Alternatively, you can go to the Object menu located here. Come to where it says Set Origin and choose from one of these options. In our case, if we want to bring our object's origin back to the center, all we need to do is go Origin to Geometry. This should bring it back to the center point, and now rotation should work the same as it did before. To change the pivot point that is being used for your transforms, come up to this icon here. Left click to open the Transform Pivot Point menu and then choose your option. Currently it's set to medium point. Now when we are using a single object, the transforms allow us to manipulate that object by itself, so the pivot point isn't that important. However, if we were to hold down the Shift key and select multiple objects, then the ability to move these objects is dictated largely by the pivot point that is selected. For example, if we change the active element, watch what happens to the location of the Rotate tool and also the behavior of our objects when we use that tool. If we were to select the light object with the Shift key and rotate, again, the behavior of our objects changes based on our selection, and this is because we are using the active element. In other words, by changing the transform pivot point, you can change the behavior of certain tools when manipulating multiple objects. If you no longer want to manipulate the transforms of a specific object, you can lock those specific transforms and their axes. To do this, press the N key on your keyboard, and this will open up the side panel. From here, you can use numerical values or click and drag operations to manipulate the free transforms of your selected objects, as well as the individual axes. However, you can also lock these transforms outside of the side panel. For example, let's activate the Move tool and then lock the Z transform. Watch what happens to the blue arrow here. We're going to left click to lock, and now the Z axis has disappeared. We're no longer able to use the Move tool to move our object on that axis. If I press the G key to activate the Move tool and then move my object around, you will be able to see that we cannot lift the object up on the Z axis. It only moves on the X and Y. By the way, you can cancel these operations by using the right mouse button to revert back to the original state. We can lock and unlock all of these separate axes on these transforms at will by using the side panel. If you want to hide an object in the 3D viewport, you can go to the Object menu, come down to where it says Show Hide, and then Hide Selected. You can also use this menu to hide unselected objects or show hidden objects. We can use Hide Selected, and the cube has now been hidden, but it has not been deleted. Alternatively, we can come up to the Outliner panel, and we have the eye icon next to each object. We can left click on the eye icon to toggle the visibility of that specific object in our 3D viewport. To apply the transforms of an object, first of all, make a change to a transform. In our example, we're going to scale on the Y-axis. To apply the scale, which is currently set to 3.1, we're going to go to Object, Apply, and from this menu, choose Scale. Left click, and you will see that the shape of the cube object has not changed, but the scale has been reverted on the Y-axis back to 1. This is what we mean by applying the transforms of an object. If we want to clear a transform, we can do so by going to Object, Clear, and then choosing the specific transform. For example, let's rotate our object on the Z-axis. You can see in the side panel, which you can access by using the N key, that we have rotated by roughly 90 degrees on the Z-axis. This is also visible in the 3D viewport. Go to Object, Clear, and then Clear Rotation. This will reset the rotation values back to 0, but it will also reset the object's rotation as well in the 3D viewport. And this is why clearing your transform is different to applying your transform. To duplicate a model, first of all ensure it is selected. Then come to the Object menu and select Duplicate Objects. Left click and the highlight of the object will become white. You can move your object around 3D space and reposition. I'm going to lock this to the Y axis by pressing the Y key on my keyboard, position it roughly here and left click. Now I have two cube objects. FYI, when you use the Duplicate tool, the duplicated object inherits the base name, which is cube, but also has a number added on the end of it, in this case 0.001. These objects are entirely independent of each other and can be edited independently as well. To create a linked duplicate, select the object that you wish to duplicate. Go to Object, Duplicate Linked, and you will see the white highlight. Here we're going to lock to the Y axis, move it across, and left click to position. This looks very simple and is very similar to the original duplication method, but there is a key difference. We're going to left click on the original cube, and then we're going to go into Edit mode, which we can do so by coming up to where it says Object Mode, left clicking, and then Edit mode. If we were to manipulate one of these faces, so I'm just going to do this as a quick example, I'm going to take the top face, hit the G key to grab and bring it up. You can see that the linked duplicate inherits the same shape as the original model. While these are technically two different objects, they are using what is known as the same mesh data. By contrast, the original duplicate that we recently created has not changed its shape because it is using its own unique mesh data. This is the difference between traditional duplication and linked duplication. We can use what is known as smooth shading to make objects more presentable in 3D space. If we were to use this on the cube, it would require us to either go to Object and then choose the Shade Smooth option. Alternatively, we can right click and we can choose the Shade Smooth option from this menu here. In the case of our cube, this actually creates a very weird appearance because it smooths out the normals between each edge. But because we have very hard edges, it doesn't present very well. I'm going to replace this with a UV sphere. This sphere is effectively a ball, but we can see all of the individual faces. You can right click and use the Shade Smooth option to make it look more like a spherical object like a ball than what it was before. We can't see the individual faces now. Alternatively, we can shade flat to revert it back to what it was before, and we can also shade auto smooth, which is a more intelligent form of smoothing. If we were to go back to our original cube object and then go to shade smooth, we would see the effect shade smoothing has, but if we go to auto smooth, we actually get a more intelligent result. In this case, it looks very similar to as if we had just used flat shading instead. To create collections which allow us to better organize our scenes, we can first of all select the object and then press the M key to open up the collection menu. We can left click here to create a new collection and give it a name. In this case, I'm going to rename it as Objects. Then select Create. This will, in the Outliner panel, both create the new collection, which we've named as Objects, and it will also move the selected objects into that collection. If we want to take an object from one collection and move it into another, just select that object, and then if we press the right mouse button, we can move to collection, and from here choose the collection we wish to move it to, in this case, Objects. In the Outliner panel, we can see that the light object has been switched from our standard collection to the new Objects collection. We can store our objects as assets to be used further along the project or even in separate projects with the help of the Asset Browser. I'm going to access the Asset Browser by clicking and dragging along the intersection located here, and this will bring up our timeline. I'm then, giving enough space, going to left click on this icon right here to bring up this menu. I'm going to come down to where it says Data and select Asset Browser. Now, for this example, we're just going to select Unassigned, which is currently empty. I'm going to make a couple of changes to the cube, so let's just scale it on the y-axis, and we're going to rename it as Box. Now I want to add this as an asset. To do so, I'm going to go to the Object menu, go to where it says Asset, which is about halfway down, and then select Mark as Asset. Now it has been added as an asset, but is currently unassigned. If we click and drag, we can position and add this asset to our current scene. We can do this as many times as we wish. I'm just going to delete each of the objects that we've just added. You can also see, if we select this object, that a new icon has appeared in the Outliner panel. This indicates that it is part of our asset library. To access edit mode and begin manipulating the geometry of your object, you can go to where it says Object Mode, left click, and then select Edit Mode. This will now allow you a new set of tools in the tool shelf, as well as a new set of menus from which you can use tools that will allow us to edit our objects. Alternatively, you can switch between Edit Mode and Object Mode by pressing the Tab key on your keyboard. If you're not sure where it is, the Tab key is normally located next to the Q key and just above the Caps key. Press the Tab key and this will allow you to switch from Object Mode to Edit Mode and back again. To select geometry, first go into Edit Mode and you will be able to select either the vertices, edges or faces. By default, next to where it says Edit Mode, we have 3 buttons or 3 icons. The active one is going to be for vertices. Left click, and by the way, if you scroll on your scroll wheel, you can zoom in and out. But left click on any of these points, which are the vertices of the cube, and you will be able to select them. In order to select the edges, we can left click on the second icon, and this will allow us to select an individual edge on our object. If we select the face icon, this will allow us to select the faces of our object. Alternatively, if you press 1, 2, or 3 on your keyboard, not the number pad, but the numbers on top of your keyboard, you will be able to swap between these 3 methods of selection. So 1 allows you to select vertices, 2 allows you to select edges, 3 allows you to select the faces. To select more than one face vertex or edge, simply hold down the Shift key while selecting, and this will add to your selected geometry. Alternatively, we can also use methods such as box select and circle select. I'm going to replace the cube with a UV sphere. A quick way of bringing up the Add menu is to use Shift and A. This is a hotkey shortcut that allows us to access the Add menu quickly. From here, I'm going to access the Mesh and then the UV sphere. Then press the Tab key to go into edit mode. If you left click away from an object's geometry, it will deselect everything. If we click and drag, we create a box. If we release the left mouse button, everything that goes within that box becomes selected. Alternatively, if I left click to deselect everything, I can press the B key. The B key will allow me to add a box using box select mode. I can again click and drag, release and select. If I was to press the C key, I create a circle, and I can manipulate the size of the circle using the scroll wheel on my mouse. Once I get the correct sizing, I can click and drag, and this will allow me to more easily select the faces that I want to edit. To come out of this, simply right click to end the circle selection mode. Alternatively, you can go to the select menu here, which has a wide variety of different tools that you can use for selecting your geometry, including tools like box and circle select, which are the most recommended ones to learn for a beginner. The ability to transform geometry is the same as it is for transforming an object. Simply select the geometry that you wish to transform, then use either the Move, Rotate or Scale tools to manipulate that selection. We can press the G key, for example, to move our object. I'm just going to right click to cancel. We can use the R key to rotate the selected geometry and the S key to scale. Keep in mind that when we manipulate an object's geometry, anything that is directly connected to our selection is going to be impacted as well. If I use the S key to scale, we make the selection smaller, but this in turn is going to change the size and shape of all of the faces that are connected to our selection. Deleting our geometry is a little bit more complex than deleting our objects. With one face selected, I can press the X key and I can choose to delete the vertices, edges, the faces, only the edges and faces, only the faces, and so on. For example, if I select the ability to delete the face, it's going to delete that one face by itself. If I were to select another face here, press the X key and choose to delete the edges, then not only will that face be deleted, but any other faces that were dependent on those edges, they're going to be removed as well. If I select another face on this UV sphere, press the X key and choose vertices, even more faces are going to be deleted, because the vertices that were deleted are important to the structure of everything that surrounds that selection. So here we have 3 examples of how the Delete tool can work in Blender: for face, for edge, and for vertex. To dissolve our geometry, first select at least 2 faces, because this won't work with a single face, and then press the X key. From here, we can choose to dissolve vertices, edges, and faces. If we choose to dissolve the faces, it would effectively remove the edge that was connecting them. So now we have a single face here to work with. As another example, let's select these 4 faces here. This time in the Delete menu, we're going to dissolve the edges. This time we have dissolved that selection, but we have also manipulated the edges of the faces that surround that selection. It has in turn created new edges to maintain some sort of structure in this area. Dissolving does not create gaps in our geometry. It will remove what we want to remove, but replace it with the appropriate geometry to maintain the structure. Finally, let's see what happens if we were to dissolve the faces or the vertices. So, with the Delete menu, choose Dissolve Vertices. And now we get a single face, but it's a much larger face that surrounds a much greater area of our sphere. This is because we have removed the vertices that those faces would have been dependent on. And in doing so, the only thing that Blender can do at this point is use the nearest geometry to create a singular face. To use the Limited Dissolve tool, we're first of all going to replace this UV sphere with a new one. So I've just opened up the Add menu with Shift and A, and I'm going to bring in a new UV sphere. Next, let's go into Edit mode. And for this, I'm going to have everything selected, press X, and then choose Limited Dissolve. Left click, and nothing will occur other than at the very top. Now, if we come down to the corner of the 3D viewport, you will have access to what is known as an operator panel. Open this up, and you can define the max angle of this tool. The greater this value, the more geometry will be removed. So if we click and drag to increase the max angle, you can see how this affects our UV sphere. The greater the value, the more geometry is removed. The lesser the value, the less geometry is removed. To merge your geometry, first ensure you are in Edit mode. Then select the geometry that you wish to merge. In our case, we're going to merge all of the vertices for the top face of this cube. An easy way to do that is to simply select the face itself. Next, we're going to activate the Merge menu. If we go to these menus up here, we can access a wide variety of options. Under Mesh, we can select Merge. Here we can choose to merge at center, at cursor, collapse, or by distance. For example, if we choose at center, we can merge the selected geometry to a single point or vertex. We can open up the operator panel and change the type of merging if we wish. For example, we can reposition it to the location of the 3D cursor. We can have it simply collapse, or we can merge it to a medium point. To extrude your geometry, first of all, ensure you are using the Faced Selection mode. This is the best mode for extruding geometry. And then select the appropriate face that you wish to extrude. Come over to the tool shelf, which is accessible via the T key on your keyboard, and select the Extrude Region tool from this location. Now select the option here, which is a yellow circle with a plus sign within it. Click and drag, and then release. This will extrude new geometry on your model. We can select this new geometry and extrude further if we wish. We can navigate our view, select new geometry, and begin to create custom shapes just by using a single tool. Extrude Manifold is a better option if we want to extrude our geometry in towards its own center. For example, let's create a scenario where we've used the Extrude tool to create some new geometry. I'm going to select this face right here and extrude it, but this time I'm going to bring it inwards. We can bring the geometry inwards, but now we have faces where we don't want there to be faces, and actually these are two faces that are doubling up in the same location because of the Extrude tool. What I'm going to do is I'm going to use the Undo tool, which is Control and Z a few times to revert to this state. Now I'm going to open up the Extrude menu by clicking and holding, and then select Extrude Manifold. Now, if I click and drag out, we're able to bring out that geometry, but if we go the other way and release, we're able to extrude in, but we don't double up on the geometry at these locations. If we were to use the Extrude tool to select multiple faces on the four sides of this cube, click and drag, they would all extrude upwards in the same direction. This is not the type of shape that you should be looking for. I'm going to press Ctrl Z to undo, and then we're going to change the Extrude tool by clicking, holding, and then choosing Extrude Along Normals. Each face has its own normal, the way it's supposed to be facing. If we click and drag to extrude, all of these faces are now being pushed out along their own normal direction, which creates a more appropriate shape. Alternatively, we also have the ability to extrude the individual faces. Return to this menu and choose Extrude Individual. Now we're going to click and drag, and this extrudes out the geometry, but also separates the faces at the point of their original edges. This is where it's different to our Extrude Along Normals, where the edges of these faces were still connected. The last method of extrusion is the ability to extrude to your cursor. This is not the 3D cursor, but the actual cursor that you are using with your mouse. Go back to the Extrude Region menu and select the Extrude to Cursor option. Then position your cursor anywhere you want and left click. This will create an extrusion to that point. Your view in the 3D viewport is also going to determine the rotation of the added geometry. But what we can do from here is we can use left click multiple times to very quickly create our new geometry. We can also click and drag to position that new geometry as we see fit. This allows us to create new shapes very quickly. The Inset tool is another tool that is best used with Face Select. Select the face that you wish to inset, then activate the Inset Faces tool from the tool shelf. Now come over to the yellow circle until it appears white. Click and drag in either direction, and this will allow you to inset your face. This is basically a form of extruding and scaling at the same time. We extrude to create new geometry at the same point of where we selected it, and then we move our cursor to scale that in, creating the inset. The Bevel tool allows us to create more smoother geometry. This is best used in conjunction with the Edge Select mode, so make sure you're able to select edges. For this example, I'm going to hold down the Alt key and left click. This allows me to select what is known as an edge loop, which terminates at poles, such as here, where we have a vertex with 3 sides. I'm then going to hold down Shift and Alt and left click again, navigate around and continue the process until I've selected all of these edges. This is just for the purposes of the example. Next, I'm going to go to the Bevel Tool, which is located here in the tool shelf. We're going to click and drag, and that's going to create a bevel for our object. This is where we take our selected geometry and we create more edges using the Bevel tool to create some curvature. While you are using the tool, scroll up on your scroll wheel to add more geometry. This is also known as adding segments to the bevel. Let's add quite a few for some smoothness and position about here. Now if I deselect everything, you can see that we've created some nice curves around this cube object. We can see this better if we go into object mode. The faces are still visible, so this is an example of where we can use Shade Auto Smooth to get a better result. The Bevel tool can also be used to bevel the individual vertices rather than the edges. In this example, I have all of the edges of our model selected. We can activate the Bevel tool and then click and drag. This will allow us to bevel all of the edges of our cube. However, I can change this by pressing the V key on my keyboard. Press V and now only the vertices themselves are going to be affected by the Bevel tool, while the edges themselves are maintained. We can scroll up once again on our scroll wheel, and this is going to allow us to add segments to make the corners of our cube smoother and more presentable. Again, we can combine this with other tools such as the Shade Auto Smooth tool to get a better result. Loop cuts allow us to create more geometry where it's required. Come down to the tool shelf, and with this icon we can activate the Loop Cut tool. Now hover your cursor over your object and you should begin to see loops appear coloured in yellow. If we left click at any point, it's going to add that loop to our object. So we can add as many of these loops as we require to very quickly add new geometry to our model. The Loop Cut and Slide tool is a hotkey version of the Loop Cut tool with a little bit of added functionality. To activate the Loop Cut, we can go to the Edge menu and we can come down to where it says Loop Cut and Slide. Alternatively, we can also use Ctrl and R on our keyboard to access it more quickly. For now, let's left click, and if we move our cursor around once again, we can position where we want to add the loop. If I left click, it's going to add the loop, but this time we have a second stage. I can now move this newly created loop cut anywhere I want along the confines of the existing geometry. For example, we could add one loop up here. I can use Ctrl and R to reactivate that Loop Cut and Slide tool, which only allows me to create a single loop cut in that instance, and I can scroll up or down on my scroll wheel to create multiple cuts. I can then left click and reposition these new cuts where required. This can be combined with other tools, such as the Extrude tool. I can use Extrude Manifold, for example, to potentially reposition, or extrude along normals, which might be a better option. And this allows me to create new shapes just by combining a couple of tools together. If we go to the Loop Cut tool in the tool shelf, click and hold, we have a second option for Offset Edge Loop Cut. Before we do this, we're going to create a single loop cut beforehand, and then we're going to change the offset version. Now from here we have our selected loop cut. We can click and drag And what that will do is it will create 2 loop cuts evenly distributed either side of our selection. We can position wherever required and release. We can do this multiple times, but it will always do so from the active selection. So if we left click again, we create more geometry. Click and drag again to create more geometry still. This next tool is best used for when you want to create new geometry in a very specific way. Come over to the tool shelf and select this tool located here. Make sure it's selected and then come over to your object. You'll see the cursor has changed, and left click wherever you want to add the first vertex. I'm going to left click, and from this location I can now add a new edge. When I snap to an existing edge, the color of that edge will change. I can left click to add the edge in, and then I can add the next one. I can also create a closed loop if I wish by hovering over an existing vertex. Left click again, and now if I want to finish this but not delete it, I have to press the enter key. So press enter on your keyboard and that will add the new geometry to your model. This is a great way of being able to add edges at any point that you wish, and is a very useful tool for the purposes of retopology, which is reformatting your existing geometry to better suit your model. The Bisect tool can be activated by coming down to this icon here in the tool shelf. Click and hold to bring up this menu and then select Bisect. Now we can click and drag to form a line. When we release, it's going to create geometry based on the angle of the line that we have created. So if I release the left mouse button, you can see that we've created this new geometry on the cube, and it goes all the way around like a loop cut. I can manipulate this gizmo here to best reposition the bisected geometry however it is required. Alternatively, a good idea when using this specific tool is to work in an orthographic viewpoint and then click and drag to more easily create that geometry. The spin tool allows us to manipulate geometry around the object origin or pivot point. For this example, I'm actually going to delete most of the geometry on this cube. I'll delete this geometry via the vertices option to leave us with 2 vertices and a single edge. With this edge selected, I'm going to activate the spin tool, which is located here. We get this gizmo, which we can then click and drag to spin around a specific axis. This allows us to spin around the origin point of our object to create what appears to be a cylinder. We can then come down to the spin operating panel, left click to open it up, and we can manipulate things like the angle to allow us to merge the geometry at the start and end points. Just make sure that this auto merge option is ticked. We can also manipulate things like the steps, which increases the total amount of geometry added. We can change things like the center point on each axis, as well as the axis value itself to create some curvature in our design. Of course, depending on how we use the spin tool, some of these values may not have any specific effect. Because we rotated on the z-axis, manipulating the z value isn't actually going to change the effect of the spin tool in this case. The smooth tool is used to create a more spherical, smoother, softer looking shape. Of course, if you don't have enough geometry, it's not going to work correctly. So for this example, we're going to add a number of cuts using the loop cut tool. With this new geometry added, we're just going to keep a single selection here, activate the Smooth tool, and then click and drag. You can see that as we manipulate the cursor, it softens the vertices at the ends, creating a more circular shape as we move in. We can better see this if we select all of our geometry, which we can do so by pressing the A key. We're going to click and drag once again, and you can see how this gradually becomes into an almost ball-like shape. We can also bring it out if we wish, so we can actually move it along both directions. This allows us to create a softer looking cube with the geometry that we have selected. Alternatively, we can use the Randomize tool. Go to the Smooth tool in the tool shelf, click and hold, and then select Randomize. We can click and drag, and this is going to manipulate all of our vertices in randomized directions. So they're all going in a different direction, creating a very random abstract look for our model. After using the tool, we can manipulate in the operator panel things like the amount of randomization, which is effectively the distance in which each vertex is moved, the uniformity of our geometry, whether we want our vertices to move along their own normals, and also the random seed value, which changes the chosen direction of each individual vertex. A very common tool to use when manipulating your geometry is the ability to move your vertices and edges using a tool known as sliding. For example, we can select an individual edge and then we can slide that edge by using the Edge Slide tool, which is typically located here in the tool shelf. With the Edge Slide tool active, we can click and drag up or down on this specific edge to reposition it. This is going to maintain the general appearance of the object itself and is used specifically to move edges and vertices across the existing geometry without significantly changing the shape. If we open this up, we also have the ability to slide our individual vertices. For this, it's best to have vertex select mode, then select the vertex that you want to move, and then just click and drag in any direction. That vertex is normally going to move along an existing edge. Again, this is used to maintain the overall shape of your object. So here, for example, I'm just selecting each vertex, moving one up, and then moving the next vertex down to create a specific shape with my geometry. The Shrink Fatten tool allows us to either increase or decrease the volume of an object whilst maintaining the normal direction of each vertex. Access the tool here in the tool shelf towards the bottom and left click. Now click and drag on the gizmo, and as we move out you can see we are increasing the volume of the object, but the individual vertices are maintaining their size based on their normal direction. So they're all facing the way in which their normals are pointing, even as we increase the size of the object. The alternative to the Shrink Fatten tool is the Push Pull tool. This is very similar, except it does not take into account the normal direction of the vertices. So if we click and drag on the gizmo, we can increase and decrease the volume in a very similar manner. The only difference now is the actual gap between each vertex is proportionally maintained. So these middle vertices here are still a similar distance away from each other, whereas by comparison, if we go back to the Shrink Fatten tool, those central vertices are all pointing the same way when it comes to their normals. So the gap between the central vertices and the ones that make up the edges increases as we use this tool. The Shear Tool is another way in which we can manipulate the geometry in specific directions. The Shear Tool is located here in the tool shelf. It's the second from bottom. We have a different type of gizmo now where we can manipulate or shear our geometry in any of these directions. So if I select this green one here, click and drag, you can see the geometry shears on the Z-axis, up and down, but it uses the Y-axis as its anchor point. If I press Ctrl-Z to undo, let's now choose the red one, and that's going to allow us to use the X-axis as the anchor point as we shear along the Y. The Two-Sphere tool does exactly what you think it does. It takes your geometry and it tries to make it as spherical as possible. To access, go to the tool shelf, select Shear, open up the menu, and go to Sphere. Now we're going to just click and drag. There's no visible gizmo, but as we drag, we can turn our cube with its added geometry into a ball shape. The more geometry we have, the more spherical the final result will be. We can open up the operator panel to manipulate this factor as well. The Rip tool allows us to pull apart our geometry. I'm going to go into Edge Select mode here and select an edge. Then I'm going to come down to the bottom of the tool shelf and select the Rip Region tool. Here we're going to take our selected edge, click and drag, and it's going to detach from the face above. This creates additional geometry, so where we had one edge here, we now have two. The connected vertices mean that the edges on either side of our selection have also been broken to a point, and so we create this gap. We also have the Rip Edge option. Go to Rip Region, and here you can swap to Rip Edge. This will extend vertices, moving the result. This is best done with Vertex Select. So select a vertex, and then using the tool, click and drag. This is going to allow us to create a new vertex and reposition. If you want to do this more accurately, you'll ideally need to manipulate it so that it doesn't create non-manifold geometry. If I use Ctrl-Z to undo, one way we can do this is to click and drag to create our new geometry, and then we can potentially lock it to an axis. For example, we can lock it to the Y-axis and just slide it across. This is a way of creating a new vertex using the Rip tool. The next method of using the Rip tool is to rip and fill. I'm going to move to another side of this cube. I'm going to go to the vertex menu here, and we have the option to rip vertices and fill. Now before we activate that, we're going to select the edge that we want to manipulate. We're going to use an edge for this, and then we're going to use Rip Vertices and Fill. Left click, then click and drag, and that's going to create new geometry similar to the Rip Region tool. However, this time it's going to fill in the gap instead of creating one. I'm going to lock this to the Z axis by pressing the Z key, bring it down, and release. Now we've created this new geometry, but we've also filled the faces in the gap, which is not what happened when we just used the Rip Region tool. The Fill tool allows us to add geometry in the gaps of our model. For example, let's take the gap that we've created here. If we want to fill this, we need to select all of the appropriate geometry. I can do so by Shift left click. Next, I can press the F key or go to Face and then Fill to fill this area. So if I press F, it creates a face. Now, a better way of doing this is to select geometry to try and create either triangles or quads. For example, I can select these two edges here, and I can press the F key to fill in the space. I can do the same on the other side, select both of these and press the F key to fill. I can do so in the middle, and here I've got more edges to select, so then I can select them all and press F to create the face here. Another type of fill is the grid fill. What I'm going to do here for this example is select all of the faces on top of my cube. I can do this by just clicking and dragging from an overhead view. I just want to make sure that I've not selected anything on the sides of the cube, and I'm just going to hit the X key and delete the face. Now I'm going to select all of the geometry that surrounds the top of my cube. We'll go into Edge Select, hold down Alt and left click. With all of that geometry selected, if I press the F key, it's going to create a single face on top. This actually has multiple edges, so it's technically classed as an n-gon. Instead, if I use Ctrl Z to undo, I can go to Face and Grid Fill. This is going to try and fill that space using a grid system with the original geometry as the reference point for that grid. You can manipulate this grid using the operator panel in the corner. By default, ideally it should be in the position that you want, but this depends entirely on your model. A faster method of adding geometry quickly without changing the shape of your object is to use the Subdivide tool. In our example, we're going to use a base cube, and we can go to our Edge menu and select Subdivide. With everything selected on our model, simply go Subdivide, and this will add geometry evenly across our entire selection. We can open up the operator panel and increase the number of cuts for our geometry. So if we increase to 2, we get a 3x3 grid on each side. With 4 cuts or 3 cuts, we have a 4x4 grid on each side of the cube. 4 makes a 5x5 cut, and so on. This allows us to add a lot of geometry across our model evenly, effectively, and quickly. The alternative, or the opposite of using the Subdivide tool, is to unsubdivide. Return to the Edge menu located at the top, and below Subdivide we have Unsubdivide. Left click to activate the tool, and you can see here in the operator panel we can define the number of iterations for our Unsubdivide tool. Keep in mind that an even number often allows for a better result or a more well-distributed result than an odd number. There might be some times though when you might want to use an odd number for this tool. For example, if we hit Ctrl Z and then we go and add some more geometry with the help of the Subdivide tool again, let's actually use the selection method and select all of the faces in the center of our face here. Once we've done that, we're going to go to Edge, Unsubdivide, and you can see how this affects the overall geometry on this side of the object. The iterations are currently set to 2. If we set to 1, we can change the pattern. So by altering the number of iterations, we can alter the pattern used by this tool to reformat our geometry. A seam is used to determine how Blender will cut up an object for use with textures. In other words, seams are used to create UV maps for our objects so that we can better apply materials and textures to those models. To apply a seam to an edge, you need to be in edit mode and then select the edge that you want to mark as a seam. Then go to the Edge menu and come down to where it says Mark Seam. Left click, and then the selected edge will be highlighted red. You can mark as many edges as you want to act as seams. Every time you change which edges are seams, you're going to change the way in which the UV mapping process works. We're not going to cover that in this video, but just to give you a little hint of how to create a UV map, you select the whole object, you press U to unwrap, and then you have a variety of different options. For example, we can choose the conformal option. Then we can go into the UV editing workspace here, where we would be able to see our geometry once we have selected it. Now, if I was to zoom in on my model once again, I can clear the seams by selecting them, going to the Edge menu and choosing Clear Seam. By the way, if I moved too quickly, I just came up here earlier to where it says UV Editing, left click, and that's why we get this interface. If I now choose to unwrap my model, we actually have an issue here because we require some seams with this method. So if I was to add seams across the top of my model, go to the Edge menu, mark Seam, select everything, and unwrap, we actually get a different result for this UV map. And this is where we can add texture images that can be applied to our model in this 2D space, which will then be projected onto the 3D object. Marking sharp edges has many different use cases in Blender. One such use case is to control how smooth shading works on a model. For example, with our default cube, if we shade smooth, this is the current appearance of the cube. Now let's see what happens if we sharpen or tell Blender to treat the top edges of our cube as sharp edges. We're going to go back to flat shading, go into edit mode, edge select, and select each of those top edges. Then we'll go to the Edge menu, and this time we're going to mark sharp. Left click, come away, and you'll see that we have highlighted these edges as a blue color. Next, return to object mode and shade smooth. This time, the shading on the top face looks perfect because all of the edges that surround it have been marked as sharp. So the way in which smooth shading is applied to the model is different now because we have edges that have been marked as sharp. Now we can cancel this by opening up the operator panel for the Smooth Shade tool and turning off the checkbox where it says Keep Sharp Edges. This ignores any edges that were marked as sharp. If you want to clear your sharp edges, just go back into edit mode, select your geometry however you want, then go to the Edge menu and select Clear Sharp. Now, with shade smoothing, everything looks as it would be expected to with a sharp cube like this, in which case we would just go back to flat shading. The Triangulate tool allows us to create triangles out of any object no matter how complex. For example, we have a default cube. We can go into edit mode and select all of our geometry. Then If we go to the Face menu, we can choose the Triangulate Faces option. Left click and it will take every single four-sided face and it will convert it into smaller three-sided triangles. There are a couple of different methods that you can choose here in the operator panel, but these won't actually affect the final result too much unless you really decide to go and use triangulate on a much more complicated object. For example, let's say we delete the cube and we're going to replace it with this monkey head. There's a lot more complex geometry here than with a standard cube. If we go into edit mode, we can go to the face menu and triangulate all of the faces on this model. We can change the methods here for our quad-based geometry, which are the four-sided faces, as well as the n-gon method, which converts any face that is more than four sides into triangles. So each of these are going to change the way in which the triangles are created on our object. And which one you want to use depends entirely on your preference. The Wireframe tool allows us to convert our geometry into a simpler wireframe. To do this, we're going to go into edit mode for the chosen model. In this case, we have a UV sphere. We're going to go into our face menu, and then we're going to come down to where it says wireframe. Left click, and then what this does is it effectively deletes the faces, but where we have the edges and vertices, new faces are generated to create a literal mesh out of our original object. So this is still actually a solid model that we've created. It's not just vertices and edges. There are faces here that are used to construct this actual cage made out of the original shape of the UV sphere. This can work with practically any shape that you create in Blender. The Poke Faces tool is similar to the Inset tool in that it creates new geometry on an existing face. But instead of creating additional faces, edges and vertices, it just creates a single vertex in the center and links it up using edges. In practice, we would go into edit mode and select a face, such as the top face of a cube. Then we go to the face menu and select Poke Faces. This creates a single vertex at the center of this face, and now we have new geometry to work with. For example, we can take the top vertex or the middle vertex used by the Poke Faces tool, hit G, then Z to bring it up, and now we have the building blocks of what look like a house or a tent. Modifiers are a great way of editing your objects quickly. To access the Modifiers tab, we need to move over to the Properties panel located here. We have a variety of tabs that we can work with, but the one that we want for modifiers is the one that looks like a tool wrench. Left click and this will grant you access to your modifiers for any selected object. Click where it says Add Modifier and you'll have a variety of different categories to choose from. Within each category are different types of modifiers that you can use for your model. To add a modifier, click the Add Modifier option, go to Generate, and then select the modifier that you want to manipulate your geometry. In our case, we're going to choose Subdivision Surface. When we do so, a box appears within the Properties panel, which grants us options for how we want the Subdivision Surface modifier to function on our model. This one is a relatively simple modifier in which we can determine the levels of the subdivision in both the viewport as well as any rendered images or animations. we can increase this level to increase the amount of geometry on our model. Keep in mind that increasing the levels using the Subdivision Surface modifier can be quite excessive on your computer depending on the current setup that you are using. Make sure to increase your levels gradually within the viewport until you get a total that looks good for your project. You can always have a higher value for the actual render and then use a lower value just to save memory on your computer. To add the array modifier, return to the Add Modifier option, Generate, and select Array. You will notice that we can have multiple modifiers on at the same time. With the array modifier, we can determine things such as the count, which is the total number of duplicates of the original model, including the model itself. So if we set the count to 4, we add 3 duplications of the model. We can also use other factors such as relative or constant offset to determine the spacing between each added array or each added instance of the array. When we're using a factor of 1 on the x-axis, this relates to the total length of the model itself. So if we want there to be space between each model equivalent to the length of the model itself, we would simply increase the x value to 2. Now there's a good amount of space between each of the models that we have added with the array modifier. If you want to remove a modifier from what is known as the modifier stack, then all you need to do is click on the X button that is located here. The mirror modifier is another handy tool to use when it comes to making your workflow in Blender that much easier. First of all though, we need to do a bit of prep. Go into edit mode and then use the loop cut tool and create a loop cut down the center of your model on both the X and Y axes. Next, we're going to return to object mode, add modifier, go generate, and then select mirror. By default, nothing looks to have changed because the object is the same on each axis. If we come over here, we have the ability to determine if the modifier is going to be displayed in the viewport. For now, I'm going to turn this off. Next, we're going to return to our edit mode, and then we're going to select the geometry on one side of the model. Here we're going to delete these vertices. So at the moment, we have geometry on one side of the y-axis. So it's currently on one side, but not the other. Let's bring our mirror modifier back into view. At the moment, nothing seems to have changed, but let's change the axis to the Y and turn off the X. Now, by switching to the Y axis, we have created a mirrored version of our geometry past the object origin. In practice, what this means is that we can take a vertex, for example, or any geometry and manipulate it on both sides. For example, I can press G on this vertex, and you can see how it's being manipulated on both sides of the model. A better example might be to add a loop cut, select a face, go to Extrude Region, and begin to create geometry on both sides of our object. This is all done thanks to the mirror modifier, which effectively halves the workload when working with objects that have symmetry. In Blender, we have access to viewport shading methods. which can determine exactly what parts of our 3D scene are displayed. By default, we are using Solid View, which allows us to view all the types of geometry used for our models. We can change our viewport shading in the top corner of the 3D viewport. The second option here is highlighted, which is Solid View. The first option is Wireframe mode. This effectively displays our scene, but only in terms of the vertices and edges. It does not display any faces. As we know, the second option is Solid View, which we've been working with for much of this video. The next option is Material Preview. This uses a form of preset lighting conditions to display materials and textures in a flat, easy to view manner. The final option is Rendered View. This takes into account lighting conditions within the scene. It is using the rendered view that we can preview and set up our actual renders and animations. Each of these viewport shading methods increases the amount of computational time it takes for Blender to actually preview the scene. So the more complex the scene you create, the more important it is going to be to work with the correct viewport shading while building up your project. To create a material in Blender, go to the Properties panel and go to the very bottom where it says Material. Left click, and you should see, if you're working with a default cube, that you already have a basic material ready to go. If working with any other objects, this is what you should see. Click on the New option, and this will create a brand new material. You can left click here to name the material. For example, I'm going to name this as Red. This allows us to create a new material, and we want to be as descriptive as possible for that material. I want to create a red material for the cube. To do this, I'm going to come down to where it says Base Color, select the color, and this brings up a color wheel. All I need to do is just click and drag until I find the color that I like the look of, and I can use that color. If you already have some colors ready to go, then you can define your color using the RGB values here, the hue saturation value buttons here, or the hex value at the bottom. You can also use the color wheel and brightness slider to determine the color that you want. So there's a lot of different options for picking the right color for your material. You will notice, however, that we cannot see the red color on our object. To view this, we need to change the viewport shading mode. We can either go with Material Preview, or we can go with Rendered View. For now, I'm going to set it to Material Preview. You can assign multiple materials to a single object. In fact, you can take each individual face of an object and assign a material to that face. For our cube, we're going to select the top and bottom faces, and then we're going to create and assign a new material. Come back to the Properties panel and click on the plus button to add a new material slot. This does not add a new material, it simply adds a location where we can store a new material. Click on the New button to create that material, left click again on the name, and we're going to rename it as Blue. Then we're going to go to the base color, and we're going to change the material color to blue. Currently, this does not seem to affect our selected geometry, but all we need to do is select the Assign button, and that is going to assign the active material, which is blue, to the active geometry, which are the top and bottom faces of the cube. You can also use your materials to select your geometry. If we want to select all of the red faces, then we just need to select red from this location and choose select. Now all of our red faces have been selected, and we can use that as a means of manipulating other tools such as Extrude Individual to create new geometry based on our red faces. Blender uses multiple render engines, each of which has its own purpose. Eevee is the default render engine of choice and is primarily used to preview scenes or to create scenes in an almost video game-like manner. You can preview how a render engine is affecting your scene in the rendered viewport shading mode. Here I'm in object mode, and what we see is Eevee. If you want to change to the alternative render engine, which is cycles, come over to the properties panel and then select the render tab. The very first option will allow you to determine the render engine. It's currently set to Eevee, but with two other options. Typically, you won't use Workbench, so we're going to select Cycles. This has a slight impact on the shading of the model. It looks more accurate, and that's what Cycles is all about, accuracy. One thing to note, when you change to the Cycles render engine, you can determine what device is being used to render the pixels. By default, it's going to be set to the CPU, even if you have activated your GPU by going to Preferences, System, and then selecting from Cycles Render Devices. But once you do that, you should now be able to select this menu and choose GPU Compute. It will take a little bit of time initially, but once it's ready, you will have a much better way of rendering your objects and scenes in Cycles. If we want to create more complex materials than the ones that we can make here in the Properties panel, we're going to need to use the Shading Workspace as well as the Node system. To access the Shading Workspace, just come up to the header of your Blender interface and click on the Shading tab. This is going to change your interface quite significantly. The two key areas though are the 3D viewport, which is using the material preview, as well as a special environmental map that you can see in the background to create some custom lighting. And directly below that, we have ourselves the node editor. Here we have the material output, which is the most important node because this defines the actual output of the material onto your object, as well as any nodes that may be connected to it either directly or indirectly. And each of these nodes is going to allow us more control over how the material actually behaves. To delete a node, just select it and press the delete key. When we do that, we can see that the red area of our object is now black. No data is going into the material output, so this is going to be the result in material preview. If we go into our rendered viewport shading, we get a similar effect when using Cycles. To add a new node, just go to Add and then choose the type of node that you want to add. Typically, you're going to want a shader node before your material output. For example, let's go with a very simple diffuse node. When you add the node in, you have to connect the output, which is BSDF, to the surface input of the material output node. So click and drag to create this noodle, and it should snap into place as you move the cursor over the surface socket. Once we've done that, we've added the material property, the diffuse property, to our object. We can then change the color to whatever we need for this material. Before we can render images, we need to set up our lighting. In this example, I'm going to take this cube object and I'm going to move it up on the Z axis. I'm then going to create a plane object to go underneath. And we're going to scale up that plane object. We'll go into edit mode. And we're just going to go edge select, take a couple of the edges, and we're going to use the Extrude Region tool to bring them up. So we have a little bit of a scene that we've created here. Next, what I'm going to do is I'm going to go into rendered viewport shading. This is important because when we're setting up the lighting, it is only using rendered viewport shading that we will actually be able to see the effect that the lighting has on our scene. Now this is just an example, so I'm perfectly happy with the object not touching the floor of our area here. What I want to do is I want to select the light object here, and then I want to come to this tab, the data tab, for the light. It should look like a light bulb. We can then determine the type of light source that we are using. For example, we could change to a sun lamp, which by default is going to be exceedingly bright, a spot lamp, or an area lamp. For now, let's stick with the point lamp. We can define the color of the light source. So for example, we could make this a little bit yellow. And we can determine the power. So if we reduce the power of the light source, it gradually makes the scene darker. We can determine the soft fall off of the light in terms of how it affects the models at a distance, as well as the radius, value, and the number of bounces. What I'm also going to do here is to make the scene more complex, I'm going to add 2 more lights. So this is going to be known as a 3-point lighting system. We're going to take the initial light and we're going to duplicate it. I'm going to position the second light over here, and we're going to make this a slightly weaker light source, but we're going to use a different color. So now you've got multiple colors illuminating the scene. The last one is going to be the backlight. So we've got the key light, the fill light, and the backlight. Again, we're going to duplicate, and then we're going to need to reposition this third light. And for this third light, we're going to reduce the power even more to under 200. And let's just make this a little bit of a green light. So now we've got a setup with 3 light sources providing a lot of detail in our scene. And you can see how the colors sort of blend together. It's important to use rendered viewport shading so that you know exactly how these lights are going to affect your scene before you begin to position the camera work. To best position your camera, you first need to actually view your scene through the camera, which is this object right here. To do so, come over to where the side panel would be. If it's currently visible, it would be by its side. If not, it will be by the side of the viewport. And look for the camera icon. This will toggle the camera view. Alternatively, you can use 0 on your number pad. Left click, and you should now be able to see a border. This border represents what would actually be the rendered image. Currently, we're cropping out a portion of the object, so we need to be able to move the camera. The best way to do this is to connect the camera to our main view. Open up the side panel, go to View, and where we have View Lock, lock Camera to View. Now, if I was to orbit or navigate as normal, the camera is going to move with my own mouse. So here I'm going to zoom out just a little bit, and I also want to move my camera up. I can do this by panning. To pan, hold down the Shift key, then the middle mouse button, and just move your mouse down so that you can pan up. This should reposition our camera so that we can now see all of our objects. When you're finished, turn this option off, and if you just attempt to orbit your scene, it will take you out of the camera view. To render an image, first of all, go to the Render tab and make sure you are using the correct setup for this render. For example, are you using the correct render engine? Are you using the correct device, which should be your GPU, as this will determine how long the render is going to take? Are you going to be using denoising for your render? So we have sampling of the pixels for the viewport, which we don't need to worry about, but also for the render. So we have a max number of samples. The higher this is, the greater the value or the greater the quality of the final image, as well as the minimum samples and the ability to use denoising. We have the option to choose our denoiser here. The actual best option is going to vary, but for me, I'm going to use optics, as this will use my GPU for denoising, while Open Image Denoise should use my CPU instead. I'm going to keep the passes as they are, albedo and normal, and that should be everything I need to successfully render this image. To actually render the image, come up to where it says Render and select the Render Image option. You can also use F12 on your keyboard. Left click, and you would simply need to wait for the samples to be completed, and your render will be done. So my render has finished, but this does not save the render. It's extremely important from here that you go to Image, Save or Save As, and then save the actual image file. If you close this, and then you close Blender, even if you save your file, you will lose the render. So go Image, Save As. I'm just going to go to my desktop for now, and I'm going to call this Render and press Enter. You can determine the file format here. There are various options to choose from, but PNG is typically the best one to start with. You can define the color depth, whether or not you're using red, green and blue, black and white, or even an alpha channel, as well as how much compression you want for the final image. Once all of that is to your liking, just select Save as Image, and by that point you will have successfully saved that render to your device. The typical way of animating objects in Blender is to use keyframes. Let's create a simple animation. Take this cube, and we're just going to move it on the x-axis to about here. If we take a look below our 3D viewport, you have what is known as the timeline. I'm just going to click and drag on the intersection here and bring it up so that we can see more of this timeline. Currently, we're on the first frame. In the top corner of the timeline, we can determine the length, so the start and end frames. I'm going to reduce this to 120. Next, we're going to add a keyframe to our cube object. To do so, we can right-click, come down to the bottom here and select Insert Keyframe. If we take a look at the Properties panel, you will see under the Object tab that all of the transforms are now yellow. This indicates that a keyframe has been added for these values. Next, I'm going to move the object along the x-axis, but before I do that, I need to make sure that I change the frame. So in the timeline, we're currently on frame 1. I'm going to move all the way to frame 120. You can see now in the Properties panel that these values appear green. I'm going to click and drag on the x-axis to move it across. The location x-axis value now becomes orange. This indicates that a change has been made, but the keyframe has not been created. Right-click once again with the object selected and insert keyframe. For an animation to work, you need at least a start keyframe and an end keyframe. If I move to the timeline controls, which are located down here, I can jump to the very start with this button and then select play. You can see across my timeline, the cube moves from its start location to its end location based on the values that I had created keyframes for. While there are many tools in Blender that allow us to create highly complex animations, this is the absolute basic form of creating a simple animation using the Blender software. Most animations that you create will adopt these principles and tools, in addition to more advanced tools such as rigging for complex models. Rendering an animation is extremely similar to rendering an image. What we need to do is we need to do the lighting, camera work, and general scene before we render the animation. This time I am going to skip most of that and just first of all demonstrate what the scene looks like through our camera. If I press play, you can see the cube moving across. Now we've already covered how to manipulate things like the lighting or the positioning of the camera, but this will do for the purposes of the video for now. What I'll do is I'll move back to my Output tab located here. This is where we can determine things like the format, so the resolution of our animation. Note that this is also the case for our renders, so if we want to create a higher resolution render, we can just change the values here. We also have the ability to determine the frame rate. At the moment, we have it set to 24 frames per second. Now you need to make sure that you calculate this with the length of the animation. So, if a frame rate of 24 FPS is being used for a 120 frame animation, that means the animation is going to be 5 seconds long. If I was to increase this to 120 and then press play, you'll notice the cube moves a lot faster because the keyframes are determined by not just the frame length and the distance between the start and end frames, but also the rate at which those frames refresh every second. For now, let's move back to 24 frames per second and make sure we're on frame 1. The other key part is the output here. By default, it's going to be set to a temporary folder. You're going to want to change this, if possible, and for me, I'm just going to use the desktop and then click Accept. You can also change the file format. Now, the PNG file format will work, but what this will do is it will generate single renders of each frame of your animation. In our example, it's going to create 120 renders. all in sequence from frame 1 to frame 120. A good workflow is to actually do this and then convert that image sequence into a movie file later on. But as we are just demonstrating beginner tools, we're going to go straight to the movie format, which is the FFmpeg. We can then determine things like the encoder and color management settings. I'm going to use an MP4 encoder or container, and then for the video, we'll use the H.264 video codec. Output quality is set to medium. Set this however you like. Typically, I like to go with high quality. With all that set up, you should now be ready to render your animation. Keep in mind that you will want to, for your actual projects, set up the lighting, as we did for the rendered image, as well as the render engine that you want to use. For now though, for the sake of time and speed, we're going to render the animation as is. To do so, go to Render and select Render Animation. Because I'm using the Eevee engine, each frame is going to render much faster than it would if I was using the Cycles render engine. However, the accuracy and level of realism with Eevee is much less than what it is with Cycles. So we're just going to wait until all of those frames have been generated. And what this will do is it will output and save the file in our desired output. So what I'll do now is I'm going to close this. We're going to go to our desktop where we should have saved our video file. With your desktop, simply select the video file, double left click, it should open your media player, and your video should ideally play automatically, or you can just press the play button to play through.